Hello grade 9 learners, welcome again to our math tutorial for this week. So I am Ma'am Fortuna Familiaran and I'm going to discuss the topic solving problems involving variations. So our learning competency for this week is that the learner solve problems involving variations. Okay, so this is our topic. Okay, what are the questions behind this topic? How is variation used in solving real-life problems? Many real-life problems can be represented and solved using variations. There are conditions in each problem which can be translated into equation and lead to find the solution of the given problem. How can I make use of the representation and description of a given set of data? Variation can be clear and understandable when one first understands what are the variables and its relation. Therefore, it is also important to know how they differ from the constants. Okay, so take note of the following questions as we go on with our discussion. Okay, prior to this, we'll discuss the four types of variations. So what are the four types of variations? So we have direct variation, inverse variation, joint variation, and combined variations. So what is direct variation? In mathematical statement, it says that y varies directly as x. This means as x increases, y also increases. As x decreases, y also decreases. So we have our mathematical equation, y is equals to k times x. Or to get the constant, we have k equals to y divided by x. Now, what is inverse variation? We have mathematical statement y varies inversely as x. As x increases, y decreases. As x decreases, y increases. So they are inversely proportional. Okay, for direct, they are directly proportional because if one variable increases, the other variable also increases. Okay. Now, how about the equation of inverse variation? So we have x times y equals to k. Okay, we multiply the two variables to get the constant, or we have y equals to constant divided by x. Okay, now let's have joint variation. So in joint variation, we have y varies directly to two or more quantities. So it's like a direct variation, but here we are going now to use two or more quantities. So for example, we have y varies jointly as x and z. So for mathematical equation, we have y equals to k times x times z. Okay, now we have the last variation, which is combined variations. So in combined variation, we have y varies directly to some quantities and varies inversely to some other quantities. So it is already a combination of direct variation and inverse variation. So for example, we have here y varies directly as z and inversely as x. So for mathematical equation, we have x times y equals to constant times c, or y equals to constant times z all over x. Okay, so these are the four types of variation that you have to remember, and also their equations. Okay, so let's have here the suggested steps in solving problems involving variations. Okay, so what are the steps that we have to follow? Okay, we have step 1. Write the variation statement into symbol. Okay, so we have to understand what is the given statement and write it into mathematical equation or symbol. Step 2. Find the value of the constant, okay, or k. Then step 3. Give the equation of variation by substituting the value of the k or constant. Okay, so we are going now to substitute the value that we find in step 2 to the equation in step 1. And then step 4, solve for the unknown. Okay, what is asked in this problem. And then step 5, check your answer. So we need to check our answer to find out whether we really solved the problem correctly. Okay, so take note of the 5 steps that we have to follow in solving problems involving variations. Now here are the problems that we are going to solve in this tutorial. So we have the problem 1. Okay, we are going to use direct variation for this. Problem number 2 will be inverse variation. Problem 3, we are going to use joint variation. And problem number 4, we are going to use combined variations. So I'm going to refer this to your learning activity sheets. So everybody, please be ready with your learning activity sheets, because all of this problem can be found in your activity sheets. Okay, so we will discuss and I'm going to explain, okay, how to solve for the problems involving variations. Okay, so we have to solve using direct variations. So if n varies directly as m, and n is equals to 15 when m is equals to 10, find the n when m is equals to 6. So given this problem, we are going to solve for n when m is equals to 6. But before this, we need to solve first for the constant. So we can solve for the constant given, okay, the first statement, which is if n varies directly as m. Okay, what will be our equation? So we have n equals to k times m. So remember, in direct variations, if a variable increases, m increases, n also increases. Okay, so they are directly proportional. So we can solve for the constant by substituting the value of n, which is 15, and the value of m, which is 10. Okay, so simplify. 15 equals to k times 10 equals 10k. Now, so we are going to eliminate 10 here. So by dividing both sides of the equation by the additive inverse or multiplicative inverse of 10, which is 1 over 10. So 10 divided by 10 is 1. Okay, so we have only k as remaining. Then 15 over 10. Then simplify this by reducing it to its lowest term. So divide both the numerator and denominator by 5. So 15 divided 5 is 3. 10 divided 5 is 2. So the constant of variation is 3 halves. So substituting the value of the constant from the original equation, so we have n equals to 3 halves m. This is now the equation of our variation. So using this equation, we are going to solve for n. Okay, so n equals 3 halves, the value of our constant, times 6, the value of our m. So simplify, 3 times 6 is 18 over 2. So n equals to 18 divided by 2, the value of n is 9. So if our m is 6, the value of n is 9. Okay, let's have now the application of direct variations. So here is our problem. The SSG of Tigbawa National High School launches a recycling campaign of the waste materials in order to raise students' awareness of environmental protection and the effects of climate change. The table below shows the points earned varies directly as the number of kilograms N of the waste paper collected. How many kilograms of papers need to collect in order to raise 60 points? Okay, so we have here the table of values. Okay, so the number of kilograms N, this is our independent variable, and points, P is the dependent. So if we have 1 kilogram collected, the equivalent points is 6. 2 kilograms is 12 points. Okay, now, so we are going to find out, okay, what will be the equation. So since the points earned varies directly as the number of kilograms N, then the equation of variation is in the form P equals to K times N. Okay, remember, it is a direct variation. So using one of the pair of points, okay, from the table of values, so we can choose any of this pair of values. So for me, I choose 2 and 12 from the table. So we are going to substitute these values in the equation and solve for the constant. Okay, so this is my given. Okay, so we are going to find out how many kilograms of waste paper should be collected to earn 60 points. So, using the equation P equals to K times N, okay, we are going to substitute. The value of P is 12 times K times 2. Okay, so simplify, 12 equals 2 times K is 2K, and then divide both sides of the equation by 2. So 2 divided by 2 is 1, so the remaining will be only K. Then 12 divided by 2 is 6. So this is now the constant of variations. So we have our equation P equals to 6 times N. So using this equation, okay, we can solve now for the value of N. Okay, so we are going to use this equation. Substitute the value of P, which is 60, equals to 6 times N. Now, divide both sides of the equation by 6. So, 6 divided by 6 is 1. So, the remaining will be only N. 60 divided by 6 is 10. So, therefore, okay, we have the value of N, which is 10. So 10 kilograms of paper should be collected in order to earn 60 points. So this time we are going to solve problems involving inverse variations. Okay, so given this, okay, problem, okay, I will read. If y varies inversely as x and y is equals to 10 when x equals to 6, then what is y when x equals to 15? Now, so we can say it is an inverse variation because of the statement y varies inversely as x. Okay, so what will be our equation? So we have here y is equals to k over x. Okay, so this will be our equation. Now, so given the first set of value wherein y equals to 10 when x equals to 6, we can solve for the value of our constant. So by substitution, okay, substitute the value of y, which is 10, and the value of x, which is 6 now. So 10 equals to k all over 6 now. So to eliminate 6, okay, we are going to multiply both sides by 6. Okay, so 6 divided by 6 will be 1. Okay, so the remaining here will be only k. Then 10 times 6 will be 60. So the value of our constant is 60 now. And then we are going to substitute the value of our constant from our original equation. So the equation of variation will be y equals to 60 all over x. Now, using this equation, we're going now to solve for the value of y when x equals to 15. So we have here y equals to 60, the value of our constant, divided by 15, the value of our x. Now, so y equals to 60 divided by 15, y is equals to 4. So if x equals to 15, the value of our y is 4. So this is now our unknown value, okay, that we find. Let's have here the application of inverse variations. The ESO officer of Science Club volunteered to clean the roadway. The time T required to do a job varies inversely as the number of people P working. It takes 5 hours for 7 volunteers to pick up rubbish from 2 kilometers of roadway. How long would it take 10 volunteers to complete the job? So, we have here the solution. So first, we are going to identify the given. So it says here that it takes 5 hours for 7 volunteers to pick up rubbish. Now, what is asked is how many volunteers, how long will it take for 10 volunteers to pick up the rubbish? So since the time requires to do a job varies inversely as the number of people P working, then the equation of variation is in the form T is equals to K or constant all over P. Then we are going to substitute the value of the given values to solve for the value of K in the equation. So we have here the equation T is equals to K all over P. We are going to substitute the value of T, which is 5, and P, which is 7. And then we are going to multiply both sides of the equation by 7 to eliminate the denominator 7. So we have 7 divided by 7 will be 1. So the remaining number variable here will be K. Then 5 times 7 is equals to 35. So the value of our constant is 35. Therefore, the equation of variation is T is equals to 35 all over P. Now, so we can solve now for T when P is equals to 12 using this equation. So we have T is equals to 35 all over 12. 12 is the value of P. Then we are going to simplify this by reducing it to lowest term. So we have 35 divided by 12 is equals to 3 and 1/2 hours. So this is the time to complete the job for 10 volunteers. Okay, we are going to solve using joint variations. if Q is jointly proportional to R and S, and Q is equals to 6 when R is 3 and S equals to 4, find Q when R equals to 7 and S equals to 2. So we have here the statement Q is jointly proportional to R and S. So our equation is Q is equals to K times R times S. Now, okay, given this uh, value, we can solve for the value of K. So we have the value of Q is 6, the value of R is 3, and the value of S is 4. So simplify, we have 6 equals 3 times 4 is 12K. Now, and then we are going to divide both sides of the equation by 12. So this will be 12 divided by 12 equals 1. So we have here the remaining variable, which is K. Then 6 divided by 12, we are going to simplify. K is equals to 1 half. That will be the constant of variations. So we have here the equation. Substituting the value of the constant, we have Q equals to 1 half R times S. Now, using this equation, we are going to solve for the value of Q. So Q is equals to 1 half, the constant, 7 is the value of R, and 2 is the value of S. So multiply this, 1 times 7 times 2 is 14 all over 2. Okay, then we have 14 divided by 2 equals 7. So the value of our Q is 7 when R is 7 and S is 2. This is our unknown value that we find. So let's have now the application of joint variation. Okay. The area A of a triangle varies jointly as the base and the altitude h of the triangle. If area is equals to 65 centimeters square when base or B is equals to 10 centimeter and h or height is equals to 13 centimeter, find the area of a triangle when base is equals to 8 centimeter and whose altitude is 11 centimeter. Okay, so we are going to find the area. Okay, if the base is 8 centimeter and height is 11 centimeter. So this is an example of joint variation because if we notice, okay, the area varies jointly with the base and height of the triangle. Okay, so solution. Since A varies jointly as base and height, then the equation of variation is in the form of A is equals to K times B times H. Then, to find the value of the constant, we are going to substitute the value of the given values to solve for K. So this one, the three given values. Okay, so we have here the equation. Substitute. The value of A is 65 equals to K times 10, the value of base, times 13, the value of H. Then, simplify. 10 times 13 will be 130. So 130, okay, we divide both sides of the equation by 130. So we have 65 divided by 130. Then simplify, K is equals to 1 half. Okay, that will be the constant of variation. So to get the equation, we have A is equals to 1 half base times height. Now, to solve for the value of A or area when base equals to 8 centimeter and height equals to 11 centimeter, so we are going to use the equation. So we have A is equals to 1 half times 8 centimeter times 11 centimeter. So we have 88 centimeters squared divided by 2. So the value of your area is 44 centimeters squared. Okay, this is now the unknown value that is asked. Okay, so let's proceed to combine variation. So when we have combined variation, remember we are combining direct and inverse variation. So here is the given problem. If P varies directly as Q and inversely as the square of R, and P is equals to 20 when Q is equals to 50 and R equals to 5. Find P when Q is equals to 18 and R is equals to 6. Okay, so we have our equation. P is equals to K times Q all over R squared. Okay, so this is how we write the mathematical statement into equation. Okay, so P varies directly as Q and inversely as the square of R. Now, and then we have here the given. So we have P is 20, Q is 50, and R is 5. Okay, so remember we square the R. So simplify. So we have 20 equals to 50 times K, 50K all over 5 squared is 25. Then, okay, we are going to uh, simplify this. So 50 divided by 25 is 2K. No? And then divide both sides by 2. So we are going to eliminate this 2. 2 divided by 2 is 1. So the remaining variable here is K. So K is equals to 20 divided by 2 is 10. So the value of our constant is 10. So we have here our equation. P is equals to 10Q all over R squared. This is now the equation. Then to solve for P, okay, so we are going now to use this equation. 10Q, okay, the value of Q is 18 all over the value of R is 6 squared. So simplify. Okay, 10 times 18 is 180 all over 6 squared is 36. Then we are going to divide 180 by 36. P is equals to 5. So this is the value of P when Q is 18 and R is equals to 6. Okay, let's have now the application of combined variation. Okay, the problem says the force of attraction F of a body varies directly as its mass m and inversely as the square of the distance d from the body. When m is equals to 8 kilograms and distance is equal to 5 meters, force is equals to 100 newton. Find F when m is equals to 2 kilograms and d is equals to 8 meters. Okay, so from the illustration, okay, okay, this boy is pushing a box now, so they are applying a force. Okay, so it says here the force varies directly as its mass, but it inversely as the square of the distance. Okay, now so this is now the solution. So first we are going to identify the first given. So and then we are going to find out what will be the force of attraction if mass is 2 kilograms and distance is 8 meters. Okay, since force of the body varies directly as its mass and inversely as the square of the distance from the body, then the equation of variation is in the form of F equals to K times m all over d squared. So we are going to substitute the value of the given values to solve for the k to find the constant. So this is the equation. We're going to substitute. Okay, so the given value of force is 100 all equals to k times 8 all over 5 squared. Okay, simplify. So it will be, okay, 100 now. So 5 squared is 25 now. So the 25 came from 5 squared. So we get the additive inverse of 25 by multiplying both sides of the equation by 25. So that is why 100 times 25 all over 8. Now, so 8. So the constant value is 2,500 divided by 8. It is 312.5. Okay, so the equation of the variation is F equals to 312.5 m all over d squared. Now, using this equation, so we're going now to solve for the value of force if the mass is 2 kilograms and the distance is 8 meters. Okay, then we're going to substitute and simplify. So 312.5 times 2 kilograms is 625 kilograms all over 8 meters square is 64 meters square. Then we divide, okay, 625 by 64. The answer is 9.76. Okay, so the unit used is Newton. So this is the force of attraction if the mass is 2 kilograms and the distance is 8 meters. Okay, so here are the exercises that you are going to solve from your learning activity sheets. So follow the 5 steps in solving problems and make sure to write the units of your final answers. So thank you for watching. I hope that you learned something from this tutorial. So keep safe everyone. God bless. Bye-bye.